Hello all, welcome to another C64 video. But this time, we are not playing a game today, because I was rummaging through my old books and stuff and I found something very interesting. It is this book here, this little wire-bound book here. Now what this is actually the user's manual for the C64. Now I still had this. I don't know where it's from. Was it from the later one, or was it from the original? I'm not sure. As you can tell, probably see, there's pages are missing on it, and I'm not showing the actual front of it. This is just showing the keys. So just like getting started. What's this? Designing a computer system for your needs. What's it say? Commodore offers a variety of peripherals that let you create your own customized computer system. We offer different types of storage, printing, and telecommunications devices, so you can choose what's best for you. For more information about Commodore peripherals, read Commodore Peripherals Guide and the Commodore magazines discussed in Appendix R, and consult your Commodore dealer. Now, that's a misnomer, because there was no Commodore dealers. Commodore machines like the C64 are actually sold on regular department store shelves like Kmart or Toys R Us or something like that. So you really don't have that much of a thing. Oh, this musical attachments. Commodore will soon offer a musical keyboard and a 3-pad percussion attachment called the Digidrum. Both products will include special software packages. These attachments will increase the music-making capabilities of the 64 computers. Yeah, that didn't really happen. Yeah, Commodore graphics, blah, blah, blah. What's this? Commodore provides a variety of graphics programming aids, including Simon's BASIC, which adds 114 powerful new commands to BASIC, including programming help and graphics commands. The Logo, an easy-to-learn programming language with turtle graphics. Fair enough. Just going on what available things you got here. The age-old troubleshooting guides. Oh dear. Okay, so this is for the C. So it's for the original Commodore we had, because this is a Commodore C, 64C, not an original bread bin model. Oddly enough, in my line of the Commodores I got this one first. My family got this one first, but I was too young to use it at the time. Oh, geez, that's a blast from the past. Look at that. Alright, so basically let's go back unpacking it. Basically, here's an introduction. Alright, the cover's missing, so see on the other side. It says here, copyright 1984 by Commodore Business Machines UK Limited. So, because I'm Australian and we get our stuff from the UK. So we get appendices and whatnot. What's this? So let's go through here. There's some people here would like to see one of these things. Print hash. What's print hash? So to write data items to a logical file. Oh, okay, cool. So I'll print things to a file. Fair enough. But this one people would really like, if you really want to. Pause the video. There's all the SID chip registers. That's how, if you want to know how to code the SID chip, there you go. It's all the registers and what you do with them. But that's not what we're going to do today, because we are going to go do some coding. So, go back to where I was. I think it was here. Yeah, you can see here, beginning basic. You can see here the pages are crap and all this, because there's a very good reason for this. This book and this book alone forced me down that rabbit hole to becoming a programmer. Alright. I became a programmer solely because of this. Because I discovered this one day and I was reading through it, and I came across all these little commands. I thought, oh no, I'll try them out. And I did, and I got better and better at it. And because of this, I became a programmer, and that's my job today. I am a programmer. So, basic print commands, we don't want to know about that. Order of execution, blah 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 blah. This. Writing simple programs in BASIC, Chapter 4. No, we don't want to do the, we already know the go-to statement. And this statement, I'll get to that. Variables, everyone knows what a variable is. So to show off what we're going to do, how this actually works, I'm going to write the code in this little program right here. It's a tiny little thing, but it shows what I'm going to need to do. Alright, so let's do this. So type new so we can clear, wrong. Okay, I accidentally stopped recording there because my mouse was in the wrong bloody window. Better check if that's still actually recorded. Okay, so it did record. Hey, cool. That's going to be fun in the editing. Alright, so let's go back over to my Commodore window here, and I'll change this. There we go. I can hide my beautiful mug for you, if you don't mind. Thank you. So, got this over here. Let's go. So we've got to type in new. So clear the memory. There we go. So we go, basically, in this encoding of the C64, line numbers are absolutely critical, and I'll show you why once I've done this. So we'll go 10, x equals... or 1.05, 1.05, yep, 20, y equals 300, 30, z equals x times by y. Follow me so far. 40. Print seats. Oh, sorry, I'm trying to type around me bloody Mikey. Seats available. And we want to end it there, and we go Y. What that line will do, it'll just say, it'll print out seats available, and the little colon, and then put variable Y, which is 300 afterwards. Now, 50, print tickets available, Z. And that will print the output of Z, which is this, which is X, which is 1.05 times by 300. Easy enough. But this time we go 60, and we're going to go y equals y plus 1. Okay. 70. Print. Hang on, I'm going to do something easier. Go to shorthand. That actually means print. It's the shorthand for print. Okay. It just saves me typing print every time. Overbooking point. Z. Okay. So now, so what's going to happen is it's going to print. Oh no, wrong one. Y. Sorry. Now since Y is 300, but we've changed Y. Y now equals itself plus 1, so Y equals 301. Now let's run this and see what we get. We get 300, 305, and 301. Now let's say I want to modify this program. Let's just say I want to change X to 1.5. So what we do, so what I've actually been doing here, every time I've been pressing enter, it's been adding that line into memory. So if I go list, it will list whatever's in my memory, which is that. So what I can do this now. If I go 10, x equals 1.5, or I could go back up here and change it here. But I don't want to. I'm going to do it here. Now if I go list again, you'd see it's replaced 1.05 with 1.5. The reason being is I used this line number. So what if, say I want to put one behind after 70? Well, that's easy. Just go 80 print yo mama. That'll do. If I go list again, you'd see in memory it's got now print yo mama. Now you see in memory it has changed the question mark to a print, because like I said, it was a shorthand for print. Now if I was to run this, you would see that this number has changed and there's now a yo mama. Now let's say if I want to put a line between 60 and 70. Okay, let's do that then. So what I can do is I can go put any line number between 60 and 70, so say 65. So 65 print just something like that, just so we can separate the coding out, and enter. Now if I run that, boom. So if I list, see, there's our complete program in memory. How neat is that? Now what's really cool about this memory thing, so if I go new, just clear the memory, so if I go list, there's nothing in memory. What I can do to push this into something else into memory, like let's say contents of a disk. So if I go load, I've got a disk actually put in here. So if I go that, which means load and load the contents of it, of that. So basically loads that and puts it straight into memory. See this? It's gone searching, loading. It's a pretty big disk. I think it's full of radiance. So I'm going to go list, and we will see that is the contents of that disk. So what I can do using that list now, I can go, let's say, init. Let's run the init. Load init, which is program init, from device 8 to screen 1. Searching for init. It is looking for it, loading, and it shouldn't load at all. Loading ready. Let's see what happens if I run it. Nothing, syntax error and 0. Doesn't matter, because that wasn't the really first thing anyway. So basically that's how you code. You basically do line by line number, and every time you press enter, adds that command to memory. So when you type run, it runs your memory. To change the memory, you just use the same line number. To add new lines in between here and there, use a different line number. There's one, so it doesn't have to be in order. Like I can do something like this. So if I can go, say 20, go to 10, okay, it's in memory. If I go 10, that, high, I suppose. If I do that, now you see the line numbers are out of order. What's going to happen? Oh no, is it going to go to 10? Is it doing a reverse loop? No. Because if I do this, you'll see something really interesting. Never mind. Actually, it should still see it. Okay, never mind. Nope. Let's try this again. I forgot to clear memory. Okay, cool. So if I go 20, go to 10, and if I go 10, print, whoops, do that. Now if I, now you see it's, oh, the line numbers are out of order. Doesn't matter. Because once they're put in a memory, it puts them in order of line number. So if I go run, still works. Now I'm going to quickly reset this. Just do a little soft reset, just so I can get my screen back. Okay, so that's basically how to use coding to do stuff like this. And of course you've got all your if statements, your for statements. Now for those who know coding, know how to program, you know what a for statement is. It's basically a loop, a for loop. So basically for this number of things, do this loop. So what I'll do, a quick one here, but to demonstrate the limitations of this basic one though. So I go CT equals 1, 2, 4. Okay? No problem. So if I go 20, print loopy loop. That's not what I'm seeing on the book here. So bear that in mind, alright? The book says Commodore 64, I don't want to do that. So we go, then 30. Now we want to go repeat the loop, so we go next CT. Now what this program will do, it's going to go CT 1 to 4. Does CT equal 4 yet? No, do the loop. Then it does next CT, so it increments CT by 1. Commodore BASIC's for loops, as far as I can tell from this book I've just read so far, it only handles integers, steps. However, so I go run. If I just go run, whoops, syntax error in 10. What did I lose? Oh, right, okay. 10, 4. CT equals 1, 2, 4. Okay, now run. Oh. What's going on in memory here? That's weird. It was 1, 2, 4, print loop. Oh! 20, print loopy loop. Oh. Jeez. Running out of mistakes. Yep, loopy loop. Loopy loop, loop, loop. And it only does it 4 times. So 1, 1, 2, 3, 4. Now, what I can do is I can change the step, how much step it takes, what are the steps to go from there to there. Because currently it's just set to whole numbers by default. But what I can do is I go 10, 4, CT equals 1, 2, 4. Then I put another one, step equals 0.5. Now if we list that, you'll see, yep, for that 1 to 4, but step it by halves. So now this should come out 8 times, because it's running it twice. There we go. 8 times through. You can also go backwards for a step to be a negative number, so you can go 8 to 2 or whatever. So basically, that's all it can do at this point. Is that you can either do loops by go-tos, which is generally a nasty way of doing it, or for loops, which is whole numbers. Now, before we go any further onto the next chapter, which is Advanced Basic, Chapter 5. I do have to say a disclosure here. Commodore BASIC is actually the same BASIC developed by Microsoft way back when. It's derived from it. It may not be the same one, but it is derived from it. Way back in the PET, they needed a coding language for the PET, and they approached Microsoft for their Altium BASIC. What is it? Not Altium. It's oh god, I don't know. But anyway, their BASIC for the machines they had, and yeah, basically Commodore got it for a penny. And they've been using them on every Commodore system just before the Amiga. So the PET, VIC-20 and C64 all had the same BASIC in it. So, this in program. Hold down Shift and press. Oh, okay, cool. There's a bounty ball. I need where is my? I don't know. Hang on. I'll be back. I'm just going to grab a reference for a tick, because this next program has some funny characters in it. Be right back. Alright, I'm back, and I did get a reference. I needed this. This is actually my Commodore 64 that I learnt to do all this programming on. It's a bread bin. Looking at the things inside, or the date codes on the chips, it was made in '84. Pretty robust. And if you can see that, angle the light, says right there, made in England. Sweet. Basically what I needed was this Q here, has a circle symbol on it. I don't think you can see that, but you can see there's a circle symbol on that Q. I needed that. Okay? Because for this next program, we're going to need that special character. Now what this is, what we're going to do is a simple animation. Alright, just a simple ball moving across the screen. So let's go back to what I was doing. So let's new, so we can clear the memory out. This just to make sure. Yep, okay. So what we're going to do, we're going to put in REM, which is basically a remark. So 10 REM, which is remark. Okay, introduction, blah 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 blah. Sprite, graphics, creating sound, blah 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 blah. Okay, cool. So let's get back to this. So we've got 10 remark. This is basically our comment. Bouncing ball, which will be ignored when it's red. Simple as that, okay? So when you see something like that, that's that. I also need a reversed heart. Anyway, print. Whoop, hang on. Remember your line numbers. 20. Print. which is control. Yep, there we go. Haha. Okay, that. Okay, now we go. Boop. What that's for, I don't know. So 25 for x equals 1 to 10. Now we go with this. We go print. Indicate. Oh yeah. Oh, okay. So this colon indicates new command on the same line. So you don't have to do a new line number for each command. Fair enough. Command print. Boop. Control cursor down. There we go. Okay. Boop. That. Next. So basically instead of saying next next x, just so instead of saying next x, we'll just go next and we'll just know it's the loop that we want. Now, so what's that going to do? Oh, that's going to print a whole lot of circles. So it's going to print a heart first, then a whole lot of these circles. And I messed up. God damn it. Oh, you're probably all yelling at me right now. Boop. Boop. I missed that second quotation mark. So, boop. Boop. Next. There we go. So, 30. 30. For 4. BL equals 1, 2, 40. Sorry if you're sitting here waiting for me to type this all out. I'm terribly sorry, but there's not really other way to do this. I could do some disk stuff, but I really don't want to. So print, space in that. Now we go Control Q. Whoop. Control Q or Shift Q. Shift Q. That's it. Control left. Or cursor left. Two vertical reverse bars. Oh, whoops, wrong one. Shift. Okay, let's put that back up. So shift left. Ah, yep. Does that. Boop. Okay. Remark. Boop. Shift. That is a shift Q. Okay, fair enough. Alright, so let's go down one more. What have we got? We've got 50. 4 TM equals 1, 2, 5. Now we've got 4 loops inside 4 loops right now. That's, why am I doing 5 loops here? Okay, so 60, next TM, 70, next BL. So what this is going to do for 40 times, it's going to put this 40 times across the screen. Why? I'm not really sure why they're doing this. Next BL. So 75 is another remark, which is basically, once again, a comment. Move ball right to left. Those who don't know programming, a comment or remark in this case is basically ignored by the program, by the compiler or interpreter in this case. So if I was to run this, this wouldn't appear at all. It just ignore it. These are basically used by programmers and coders to describe what a particular part of programming is actually doing. In this case, it's saying this next bit of code is to move the ball right to left. Okay, so 80 for BL equals 40 to 1 step equals minus step is minus 1. So it's going to go across then back again. All right. That's it. Bouncing ball back and forth. Okay. Oh, okay. Sorry, I was just reading ahead. Where are we? Not at 60. God damn it. I just overwritten that. 60. Next. TM. Let's do a list just to be certain. Alright, cool. 80. I made a big boo-boo. 4BL equals 40 to 1 step minus 1. Enter. Print. Oh, hang on. No. 90. I've been doing coding without line numbers for so goddamn long. Print. Now there's a space here. This is for a reason. So shift left. Now this, from what I can see, is actually erase a character. It's a special character to erase something, I believe. Left, shift Q, cursor left. What that does, I have no idea, but we'll see. Okay, I think these TM ones are just basically delays. 100 for TM equals 1, 2, 5. 110 next TM 120 next BL, which is this one here, and then we do a line that makes it just repeat itself. The program just repeats itself at infinitum. So we go. So if we list, there's our program. That's fine. So let's run it. See what we get. Syntax error and 25. What am I missing? Oh, there's 2 prints. Why is there 2 prints? So 25, that print 10, print that next. Okay. So we'll go back down here. So if I do a list again, it's better. So let's run. Oh yeah, you see the balls bouncing back and forth. Okay. Why did it have that stuff in the beginning? I don't know. Oh, that's probably just to clear the screen. That's what that does. Right, that heart thing at the top clears the screen. So if you print it, clears the screen. Okay. So now it's just doing that shape. And so the ones before it must be, I don't know. Let's have a look. What's on the next page? Okay. Line 10 is a remark. Yep, remark statement has no effect on the program itself. Line 20 clears the screen. So let's escape this list. So line 20 clears the screen. So that clears the screen. Okay. Line 25 prints 10 cursor down commands. This just positions the ball in the middle of the screen. Without this line, the ball would move across the top line of the screen. Without this line, okay. Line 30 sets up a loop to move the ball 40 columns from left to right. Line 40 does 3 things. It prints a space to erase the previous ball positions, prints the ball, performs a cursor left to get ready to erase the current ball position again. Alright. So this here just means move the cursor left. What? Oh, okay. I think. Okay, to raise the current ball position again. Line 50 and 60 set up a loop that slows down the ball's movement. Without this loop, the ball would move too fast for your eyes to see it clearly. Line 70 completes the loop set up on line 30 to print balls on the screen. Each time the loop executes, the ball moves another space to the right. As you can see from the illustration, the program contains a loop within a loop. You can include up to 10 loops within a loop. The only time you get into trouble is when loops cross over each other. The loops have to be nested inside each other. In other words, if you start loop A, then start loop B inside loop A, you must finish loop B, the inside loop, first. A maximum of 9 loops may be nested this way. When you are writing a program with loops, it's a good idea to draw arrows from the beginning of the loops, from the beginning to the end of the loops. If your loop crosses, the computer can't figure out what you want, so it can't execute the program. Lines 80 through 120 just reverse the steps of the first part of the program and move the ball from right to left. Line 90 is slightly different from line 40 because the ball is moving in the opposite direction, and you have to erase the ball to the right and move to the left. Line 130 sends the program back to line 20 to start the whole process over again. For variation of the program, change line 40 to read. Okay, so 40 print shift Q. Okay, so let's run this. Alright. Then it goes down. That's cool. Okay, that's cool. So because you left out the cursor control, each ball remains on screen until it's erased by the ball moving right to left in the second part of the program. Just some input saying ask him for user input, blah 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 blah, using the get statement. Get lets you input one character at a time from the keyboard without pressing the return key. This really speeds up entering data in many cases. When you run a program that has a get statement, whatever key you press is assigned to a variable you include in the get statement. Here's an example. Okay, so if I go... Okay, so just go new, thank you. So 1... shift control home, whatever that does. Okay, cool. Alright. Let's go away. Boom. Okay. 20, not 10. Get a $. If a dot, so basically anything with the $sign after it is a variable. In this case, it's an input variable. That's what I'm saying. It's a variable that's been used coming in from the user's input. If a equals then 10. Alright. So whoop. What's going on here? Whoops. Okay, then 10. I don't know what's going on. 20. Print that. Boop. 30. Go to 10. So let's check our code. Okay, so apparently line 1 clears the screen. Okay, so basically what's going on is it's going to clear the screen, then it's going to sit here in an infinite loop on this line waiting for an input, because if there's no input then it just sits there, it just repeats itself. Once there is an input, it goes to next, prints out that input, then repeats the whole process again. Well, not the whole process, it just goes back to that line. So if I go run, okay, it's now just sitting here waiting for an input. 6, 3, 2, I don't have to push enter, it's still doing it. Whereas all the other inputs are waiting. So if I type in the escape, sorry, I'm just going to do a full blown soft reset, which is basically saying just flicking the switch. So if I do say 10 input $1, okay, cool. 20 print that, run. Okay, looking for something, looking for an input. What can I put in? Say 5. Doesn't matter. Okay, I've muddled that up. I think I modeled that up. Did I? Must have. Okay, let's try this again. 20 print a that. Saying it's a variable. So if I run this again, 45. Never mind. I don't get. Okay, let's move on. Print you typed. Oh, right. Okay, 20. Let's try that again. Oh, why am I doing print twice? With that. Okay, run. That should work. 56. 56. There we go. I was doing print twice. Got me shorthand and longhand all muddled up. So basically, let's get in the thing. Using program to get your function keys. We don't want to really do that. Just basically using a character map. Some random numbers. Don't need that. Guessing game. Some random graphics. Alright, as an end to this, let's do some funky graphics. Because I've been going on for nearly 50 minutes. Around 45 minutes according to Audacity. So let's do this one. So new. Okay. Let's go. 10. Print. Control. No spaces, I think. Okay. Oh, I still thought I was typing in text. Okay. That 20. Now we'll go 20. Print. Oh. Okay. This should be interesting. Char, which is character input. So basically a keyboard map. Basically random keys. So 205.5 plus, whoops, plus R&D, which is random, 1, which is your seed for it. It's a seeded random number generator. So 30, go to 20. Now list it just in case. Looks alright. Okay, so run. Oh, look at that. Now that looks freaking awesome. I did make a bit of a boo-boo, but on that cool little maze thing there, that is really, really amazing. That is really amazing. So on that note, on that amazing note, I think I'm going to have to... Alright, so char input is a character string, gives you a character based on the standard code number from 0 to 255. Every character in C64 can print is encoded this way. Appendix F indicates the thing. So let's see if I can find the appendix. So that's your musical note values. Okay. Programs. Oh, the serial I/O. Okay, nope. Nope. Oh yeah, there we are. Okay. I'll just go grab me for a tick. See, in the appendix here, we have all the characters that can be done. This is the C64's character map. Hey, hey. So there's that, and also as I was just looking at before, here's your screen memory map, and some more characters over here. So here's your screen memory map, and so you can actually poke your color memory into these values here. Actually, I might do that. No. That? Oh, that's screen memory map. The following chart lists the memory location placing control placing characters on screen, which locations are used to change individual character colors and show character color screen. You can actually poke values into your color memory location. Okay, and there's some more things. This is stuff you really don't get much more anymore. Is these things, your hardware details, your pinouts, the voltages, what they do and what they don't do. It's really cool. Program to try. No, I don't want to do that. Error messages. Yeah, don't need that just yet. Standard convert. Okay. Oh, so here's the differences between standard basic and C64. Stringed statements that declare the length of strings. The statements such as dim, a, ij, blah 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 should be converted. You don't need the length. That's cool. Their functions are used to take substrings of strings, formats as a $1 to access the first character in a or to take the substring of A to position A to G must be changed as follows. Set B and C equal to 0. Some basics allow the form. Commodore BASIC would interpret the second equal sign as a logical operator set. Instead, convert the statement to okay, fair enough. So you can't do simultaneous assignments. And for the SID, here's an appendix for you. Musical notes. There's that. Sorry, if you want to pause the video and you see all your notes, you want to do some SID coding, there's that. Which is the oscillator frequency and the cycles per second. And here's some more for you. And it even has the filter settings, if you want to use them. And some bibliography and blah 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 blah. The sprite register map. There's a lot of stuff in here, which is so cool, which I really miss. And we got even this, the 6566 and 6567, the VIC2 chip register map. Check that out. That is cool. Anyway, the sound control, blah, 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 blah. Some more SID settings. Some more of it. Okay, so with that, I'm going to say goodbye and on all this. If you want to see some more coding, so like doing some SID sounds, some sprites, and what have you, please let me know, and I'll see what I can do. I would love to do these again because, yeah, everyone's played the games before, but I haven't seen much of actually coding on these machines. So if you'd like to see more of this, please let me know, and I'm more than happy to do more. So with that, I'm going to say goodbye. Ta-ta.